Yes. Good morning, everyone. So today is the first session of the PySpark training. I would like to give you some introduction about PySpark and about the structure of our syllabus also. Before starting, like today is the first session, so let me give my introduction and you also give your introduction. I will announce the name one by one, then you can speak about the experience you have and the background and yes. So I am myself Vasundhara Rani Srivastava. I am having a 15 plus years of experience in ETL and PySpark. So I'm going to start your class with this PySpark with basic Pythons. And in middle, there is one sir. I will try if he can take from PySpark project onward or in middle onward. Yeah. So I started my career from Amdocs Private Limited as a ETL testing engineer, and then I have shifted to Informatica, then Ab initio. I worked in Ab initio up to 5 years. Then I have shifted to Snowflake Cloud and then Python and then PySpark. And then currently this PySpark and Python is booming now. Why? Because of AIML is came in picture for that purpose also. And many students used to ask this question like what is the future of PySpark and all. So on that also we will reflect a few lights of that. So before starting, could you please introduce yourself and about your experience one by one? So Tyaga, yeah, please start.
Yeah, hi. Uh, I'm Yaga from Chennai. So I have around 10 years of experience. I'm in mixed experience. Initially started my career in different field, and then I shifted to IT. So in IT, around I have 7+ years of experience. So in 7 years of experience, mostly in ab initio ETL
Okay.
and ab initio Teradata Linux. So after that, with my own interest, I have learned Databricks and Snowflake. And since there are many conversions are going on from ETL projects, so I decided to learn PySpark.
Yeah. Okay. Thank you, Tyaga. Then your name is Tyaga or Tyagarajan exactly?
Tyaga Sangaya.
Okay. Fine. Then Satish, could you please?
Hi, I'm Satish, having 10 plus years of experience. So I started career with as a MIS and then later prod support. Then on ETL talent, I worked for a couple of years. So right now I am working on like talent migration to Java. So there I am working as I am testing the data, comparing the talent and Java generated files and working with the partners to ensure there is no discrepancy. This kind of works I'm doing now.
Yeah. Okay. Thank you. So we will start the session with the basic introduction about what is the journey from starting from the COBOL, right? The very basic data processing system till the PySpark. So today's structure of class is this only, like basic introduction. Then some people are new for Databricks, so I will show you how to make account on Databricks. The basic account actually, it's not show just a site introduction, and then Google Colab basics like just for creating account. This much we will do. Then from tomorrow we will start the Python. In Python, few concepts are very important to learn, like basics, then functions, then lambda functions, and after that oops concept, class and all. So till oops concept we are going to cover. Apart from that, I'm like from interview perspective, they ask sometimes Python questions and pandas library also. So we'll try to cover pandas library. Otherwise, we will directly start with PySpark only. Yeah. So basics Python is compulsory, so that will be start from tomorrow. Right. So let's start from today's session. So today we will have a journey of 60 years or 65 years, I think, of data processing from starting from COBOL to the PySpark. So this historical understanding is important because that is the base of and for understanding what is the importance of PySpark and many kind of questions asked in interview, that is based on common sense, we can say, and that common sense will be built if we know the history of what was the sense behind the PySpark, right? So that's why this is the very important to know that how the data processing tools are evolved as per the timeline on the timelines. Yeah. So starting from the very basic, like in 1959, the COBOL and CSV files was going on, and the batch processing was there. And the data, like it was very slow but groundbreaking at that time, right? So at all, like there was a limitation of sequential access only, and it was slow also and can work only on CSV files, not on any other file format, although at that time there was not evolved that much, file formats also not evolved that much, so it was working. Then it was beginning of the business data processing and common business oriented language, the COBOL was. It was used in business and finance for companies and governments, and allow the storing the data file, like ETL process you all are aware about. So I'm not starting with ETL, extraction, transformation, and load. That is the base of any data processing or any data industry. So that is the main business also. So that COBOL also was able to do extract, transformation, and load. So it allowed to store the data files, CSV files, create the index file, and process data efficiently at that time. Widely used on mainframe computers and used for large scale based transaction presenting the jobs. Then after that, as the market evolved and more different type of forms of the more different type of file formats are arrived, then came the Oracle and RDMS in 1970 around. The Oracle came, and then up to 1977 RDBMS. So they made the queries instant, but there was also like stuck on one server only. It was monolithic or single server process, and it was also it is started with the tables, like storing the data into tabular format that was more structured manner, and it was easy for query processing and more efficient than COBOL. And then comes the Teradata as well. Teradata having its own feature for JDBC ODBC connection. So complex query processing, it was JDBC ODBC connection means with SQL, it can apply the programming logic also on the data. That is the importance of JDBC ODBC connection. Like one is to extract the data, transform it, and load. Another is applying programming logic also. Like in Ab initio also, we used to apply programming logics much efficiently like that. So that was going on. Then data was the beauty was that the data was stored in a structured tabular format, and it was a very much impactful, and huge change was came in the industry, and they started on preparing so many data warehouses, databases, and SQL was evolving, and PostgreSQL and Teradata. Right. So innovation was the SQL language and querying. So what they used to offer, the SQL, the easy data query language, then scripting language such as PL and PLSQL and Transact SQL script can be written, big SQL scripts can be run. It was also batch processing only. Interface for other programming language like JDBC, ODBC connection. So not only have a strength of SQL, but also the strength of programming language. You people are good enough to understand what is the SQL strength and what is the strength of programming. Like in SQL, we can do basic data processing. We can do DML, DDL, DCL, TCL operations, right? Select query, and then insert, update, delete, and then commit and rollback. Okay, those are operations. But if we want to loop the data, use the some functions, looping, if else can be possible in SQL also, but more looping concept or more functional concept, modular wise approach like classes in object oriented programming we use. If we want to apply that all kind of talent, that we need this connection. Like Teradata is the first, which around first only, which introduced this connection, and the programming logic was also applied on the data and the combination. So yeah. So this is the three-strained interface: SQL, PLSQL, and TSQL, and ODBC JDBC connection on which the RDBMS was standing upon. Then there was now so in when the 1980s the Teradata arrived, so it introduced the parallel processing also. We will go through with this, but before that I want to just introduce about what the Teradata has done. So Teradata has introduced the parallel processing. It could split a query. Parallel processing means there are two type of thing. One is data, one is query, right? So entire data can be splitted into number of n number of nodes or n number of machines, and that can be work in parallel. That is parallel processing. If it is a huge data, it can be divided into chunks and split across multiple servers. So those multiple servers are working in parallel, producing the result, and there is some program which combining them back and then giving an output. Like people who worked in Ab initio, they are aware about parallel processing. Even Informatica people also aware about what is the parallel processing. So that was first introduced by Teradata, and Walmart used it, FedEx used it, but Teradata was expensive. What is the issue with Teradata? It was expensive, very expensive, millions of dollars. Only big companies could afford it, right? And at the same time in 1980s, there was bombardment of file formats like JSON, XML, PDF, images, video files, audio files. Internet also started to explode, right? So three type of data file format, or three type of structure, we can say three category of structure they have divided it into. What kind of three structure was there? So structured, what the structured means, CSV file is loaded into tables, RDBMS Excel file. These all are structured data up to now, like till 1980s, it was going on well. So on the structured data, it was working, and query processing was happening, reports was getting generated, so data analysis was happening, and yeah, everything. So after that, when the internet started to bombard, and so many technology evolved after 1980s, then JSON, XML, YAML, and as well as PDF, images, audio, video, all file formats started to appear. Then there was the data was divided into three formats, like structured, semi-structured, and unstructured. So structured means CSV or RDBMS table. Semi-structured means JSON key value pair. You can understand by that. So JSON, XML, YAML, all having key value pair format. I will show you some. Yeah, this is the structured, like tabular format or CSV format, like this. This is CSV comma separated the file delimiter, right? CSV comma separated, and tabular row and table approach. This is structured data on which RDBMS work, but RDBMS can't work directly. It can't work on semi-structure. There is some way by that it can work, like load and process. Pre-processing is needed for semi-structured data. Load it into one table in one column and then flatten it. Key value pair need to flatten and convert it into tabular. Then RDBMS can work on that. But there are other technologies also who can directly work on JSON, like PostgreSQL and all. So this is like a sample JSON, and this is a sample XML. How it looks like a key value pair, like name and the value, time and the value, location and the value. So this is one row, we can say one record, and then second record, and this kind of one lab related one set, and then imagine related one set. So it is very complex JSON. There can be simple JSON also. So it's not very complex, but little complex is there. Similarly, this XML, this is simple XML actually. It is having only 1, 2, 3, 4, 5 columns, and their data, like their records, 1 record, 2 record, 3 record, like that. In structured format, we have fixed structure. Structured means fixed structure. Number of columns are fixed. Their data type is fixed. Size is fixed. That's why they are called structured or fixed structured format. In semi-structured, number of column may vary. Size also may vary, right? And in unstructured, that that was actually the data. Unstructured data is the main cause why the big data came into the picture. Big data was introduced. So unstructured data means text file already there, docs, images, videos, PDFs, .jpg format, .png format, .pdf. All this format was .mp4. All was introduced in after 1980s in a mass amount. Google was receiving so much data, and how to process this much huge amount of data, where to store, how to process, this was the question. So for answer of this question, the big data came into the picture. Okay, right. So up to now, any question? Yeah, there's 3 type of data: structured, semi-structured, and unstructured. This is the basic JSON example. Like JSON having this kind of instead of tables, it will have a key value pair like customer ID, name, age, order, 4 columns, right? 4 columns. If you imagine 4 columns are there, and then ID 1, 2, 3, 4, 5. Name is John Doe. Age is 34. Order is they having 2 records. So a vector or whoever working in the Python, they can understand a list of 2 set, or whoever is working in ab initio, they know vectors, right? So vector of 2 records, like that. This order is not a string type, not a decimal type, but a vector type or a list type. And this list is called vector in ab initio, array in a C++ or a Java, right? Like that. So yeah, like this you can understand. So this kind of how to process this kind of data, right? For that there is in Snowflake Cloud also there is a facility for that. How to process PySpark also have facility. Even ab initio also have that facility now. Means not now, from very early days, right? So this kind of file format, XML file format, JSON file format, that was evolved. And these smartphones, social media, IoT sensor, e-commerce, right? All this changed everything because of 6.8 billion users, billions of posting daily, billions of devices, clickstream and behavior data from e-commerce, like many Amazon and many different applications are there. From there, lots of customers are ordering something daily basis, billions of data was received, and terabytes or petabytes files are there to process now. And one single system, RDBMS, what is the issue with RDBMS? Single system issue. It can work on single system, it can, but a single system can't tolerate, fault tolerance will not be there, and there will not be able to accommodate that much data, terabyte and petabytes of data. And how what to say about the processing that, right? Then three V's problem of big data. Big data's 3V problem. What is volume, velocity, and variety? One is variety, different variety of data, JSON, XML, Perquet, all this file format. And one is the petabytes of data, how to store, right? Another is they need to process in seconds. Okay, they want to process it in seconds, not in hours or minutes, not even minutes. Okay, the suppose on Amazon today millions of customer has ordered, suppose. Okay, it want to process it immediately. That means in process means it should reflect on the Amazon server immediately, and the clerk who is sitting on that like OL two type of things are there, OLTP, OLAP. So OLTP work is done by clerks. So whoever is handling this transaction, order transaction, whoever is looking after the who has orders and how to supply demand. So those people should see immediately what order was placed. And what to say about Amazon, it deliver in at least 1 day, 2 days, 7 days. Say about Zomato, it delivers within very less time, and Blinkit more faster, right? Now, current day scenario is like that. So they need the data immediately. If from here you do transaction or order, there it should reflect within a second, not in a minute also, right? Otherwise, some other person, like if some website is loading late, or somebody will switch to other platform, like Flipkart is doing late, then somebody will go for some other site, right? Or any then Flipkart is not late now, but just giving for example. But this is the thing, like petabyte of data and high speed is also necessary. Apart from that, the acid property, concurrency, concurrently many user are doing transaction. So I give the example of retail warehouse, but in banking more complex, like a transaction, then there is a fraud detection and many things need to be do in very fast speed, right? So then the big data came into the picture. So in 2006 around, the Hadoop changed everything. And big data means, this was called the big data generally, which is having a huge volume, which need to be processed with high velocity, and that can handle the variety of data like JSON, Perquet, XML, all kind of variety of data, right? So up to now, is it clear what is big data and what was the problem of big data? Okay, guys, today is the theory question, theory only. Okay, so if anything you want to comment, add up, yeah, you are free to add up. Like I used to take a interactive classes only, not the monotonous. Yeah, anything, or is it good from your side?
Yeah, we are good.
Okay. So why the RDMS fails for processing big data is, big data means this three things. Well, huge volume, petabytes of data need to process in seconds, and variety of structure. So it is designed for single server. That is the main issue for RDBMS. Monolithic process, single server process. Single server can't handle that much huge data. They can't create that much big hard disk, single hard disk or a few hard disk on single server, which can handle this much petabytes of data. That was first challenge from hardware side also, and programming side also, software side also, they can't process also. So they can't process that much big data if somehow the storing also possible. So cannot handle semi structure or unstructured data. That is another challenge. It can work on only tabular format, CSV format, but not on the JSON or Parquet. So very expensive to scale up. Scale means, here there are two type of scaling is there, guys. Remember, many time interviewer ask what is vertical scaling, horizontal scaling. Okay, so there are two approaches. One is single server approach, monolithic. Another is distributed approach, which we are going to see just in few minutes. So in single server approach, there is always a vertical scaling happen. Vertical scaling means you have a one server and you are increasing the resources of it. Okay, so you have suppose a one server of two core CPUs. Okay, core to do two CPUs and four hard disk of 2 TB each and several RAM size. Right, this only define the server. Server's resources means what? CPU, hard disk, and RAM. Okay, so it will have some limited CPU, hard disk, and RAM. Now scaling means what? You increase that. You increase the server, you increase the CPU, increase the hard disk, increase the RAM. That is means vertical scaling a single system. So single system, if you are scaling or increasing the resource, that is called vertical scaling. And horizontal scaling comes in the distributed system terms. So what is distribution? We will see just. Right. So very expensive to vertical scaling. Why it was expensive? Because suppose a big IBM server is running, right? A single server. And if you one need to now up to now it was running properly, everything working. So many things are lying on that daily basis, batch processing happening, data getting generated. Now if they need to scale up, then they need to contact the manufacturer or the hardware people, and then take all the operations in the account without changing those operations, then scale up. So that was a very expensive and costly to do on hardware level. Then no fault tolerance. If suppose everything is stored in a single place and something happened to that place, then everything will lost, right? If you distribute the things on different places and some single place is lost, then only that much loss will happen, not entire loss, right? So that's where the even the money also we used to recommended that don't do one FD for entire 1 crore, right? Divide it into chunks and then do several different FDs. That kind of. So that is recommended because if single failure or something need to liquidate or some failure happen, then remaining will be saved. If everything will be on single bank and if that is drawn or that is gone, then the things will be huge loss. So that's what about the data. So if everything is stored on single server, if anything lost, then entire process will stuck up, entire company may become bankrupt. So fault tolerance issue, these 4 issues was there in RDBMS. So what about the big data? So in it can store the high volume of data. Like big data means actually the Hadoop came in the picture of 2006, and that changed everything. It did parallel processing on cheap servers, and any company could afford big data at that time in 2006 by using Hadoop. That's why Hadoop was very much famous in 2006. So but Hadoop was also having some issues. We will see that everything has some limitation up to yeah, in this material world everything has limitation. So big data that store the high volume of data arriving at a high velocity, right? Daily basis petabytes of data, you can understand by that. Accommodate all variety of data, structured, semi-structured, unstructured, and process high volume of data with the high speed. All 3V problem can be solved. That was the big data system needed. Right. So if summarize, we are discussing about the data processing is one of the critical business requirement, and RDBMS is used for decades to develop data processing application. Then the bombardment of internet and internet related smartphones and all these technologies, and then their variety of data structure was came into the picture, and huge data and in great speed they need to process. So business started to collecting high data volumes, need to collect and process data at high velocity. New data challenge is popularly known as big data problem. The big data problem was declined using the 3Vs, variety, volume, and velocity. RDBMS failed to handle big data problem. Industries need a new approach or platform for big data problem. Right. So two approaches are there in big data. One is monolithic and one is distributed. Monolithic means I just explained single server. Everything is on single server. And distributed means many computers are working together as a one unit like this. So uh, this is monolithic approach which RDBMS was following, having a single CPU, RAM and disk. And distributed approach means multiple CPUs working in as a one unit. Everyone is a single server on its own, but they working as a common unit of single server like that. So that is the Hadoop concept actually. Hadoop has brought distributed approach in picture. So it this particular node or server will have its own CPU, RAM, disk resources. It will have its own disk, RAM, and CPU resources. Like that, every have its own, as well as how to work them in parallel. That parallel and parallel processing came into the picture. Like if you receive some file or a big file of petabytes, then you divide it into 4 machines, and this one machine is can be capable of this much big, as well as can be have a small size also. So vertical scaling also, vertical scaling means increasing for single system. Here also, if you increase for single system, you make it more big, more RAM, hard disk, that is vertical scaling. Here we have two type of scaling. One is vertical and one is horizontal. That means increasing more machines. Either one can increase more machines or one can increase single machines storage or CPU or RAM. Right. Now, three type of criteria is there: scalability, fault tolerance, and cost effectiveness. Yeah, so scalability means vertical and horizontal, I just explained. Then fault tolerance, also I explained you that primarily here if anything will happen to single machine, then everything will be lost. But here if anything will happen on single machine, like this machine doesn't work anymore, or any hardware failure happen, disk failure happen, anything happen here, so remaining will work. Only single machine will fail, so data is not stored on single machine, it is distributed, so remaining data set will work, only some loss will be there. This is what. Then cost effectiveness. So if any vertical scaling or anything need to do, then this will be costly. But here you can start with a very small amount via simple machines, simple machines or simple servers. And then later on when the business grow, then you can increase the machines, horizontal scaling you can do or vertical scaling you can do. So like that, one can start this from very basic and can go on for expense as per the economics. So distribution approach was economic. That is the meaning. And monolithic approach, in the starting only one need a very good infrastructure with like $500K or $2 million upfront. And distributed, it was start with small, grow gradually. So it was economic, more economic. And monolithic was expensive. This is also many times they ask in different interview questions, either data engineering related jobs you apply or any what is the monolithic or distributed approach, or what is the single server and parallel server approach. This is the concept having different names. So on the basis of three features or criteria, you can explain the differences. Okay, scalability, fault tolerance, and cost effectiveness. If any question is there, kindly interrupt in middle. So distributed approach wins because of it can do both vertical and horizontal scaling. It can do fault tolerance, cost effectiveness, handle all data types, right? So data processing is one of the critical business requirement. We used RDMS to decades to develop the data processing applications. The advantage of the internet started putting following the processing challenge, this three type of variety of data. Then business started collecting high volume. This all we have learned up to now. Then industry needed new approach, and Hadoop came as a distributed big data processing platform. Now, what was the Apache Hadoop and how it works? So there was limitation of Hadoop also that we will discuss later on. Like it was slow actually. That was the main issue. It was the slow and it takes processing time, then high resolve, that some issues. Complexity, data complexity, processing time, that was still came into the picture. And it was taking lots of time also for processing. Like processing time was not completely resolved by Hadoop. 3V problem, right? One is big, huge volume of data. It can store huge volume of data. It was so because of this horizontal scaling and all. But processing time, it was unable to reduce. That's why PySpark come in the picture. So we will see that all. And third thing is it can use only Java. It can't use the Python, which was evolving and using less code, right? Python having less coding and more module. And it was evolving, and nowadays we can understand AI ML is fully based on Python only. So that's why PySpark came into the picture later on. So Hadoop having those limitation, like one is processing issue, another is it can't use Python. It can be only on Java. Two issues. Okay. So keep it in mind. We will just go through from Hadoop layers one by one. So yeah, 3-layer approach it having. So from 2006 to 2014 was a Hadoop era. It was like they was working on the Hadoop, and it has resolved the issues up to some extent. There was 3-layer approach: Yarn, HDFS, and map and reduce. So if you apply for PySpark, PySpark took birth because of Hadoop only. Hadoop was failed, then PySpark came. So that's why sometime interviewers ask some this type of questions also, like what are the 3 layers of Hadoop, and yeah, what are the uses of them, and this kind of questions. Then data lake and data warehouse, those all also there. Yeah. So one by one we will see this 3-layer. Yarn, cluster operating system, then HDFS, distributed storage, and map and reduce, distributing computing. You can understand this. Yarn is the manager. That if you see this distributed approach, if your data is distributing on this all machines, so HDFC can HDFC means storing data warehouse. HDFC is data warehouse, which is storing the huge data, the petabytes of data divided and stored in it. Okay, I'm just giving you high level understanding of what is how the HDFC 3-layer works. So HDFC Hadoop 3-layer works. Sorry, HDFC means storing the data. Yarn means managing. Now you need to manage them. Which data is gone to where, and recollect back. Right. So all the things need to be managed. And map and reduce 3rd layer is to process them. Okay. So we will see in detail how they works. That is the basic understanding. Not usable. Yeah, there is the one basic fundamental requirement, like the single monolithic approach, not usable without operating system. Like anything will not work without OS. If you purchase a new laptop doesn't have OS, or new mobile doesn't have OS, you can't install any application until and unless you have some operating system, right? Either Linux or Windows, or on mobile Android. Okay, so that is the basic requirement for monolithic. And for the hybrid, for this distributed Hadoop, you have the basic requirement, not only OS but the cluster OS. Okay, so cluster OS should be there. That was the main requirement. Without cluster OS, you can't run this thing like Hadoop or horizontal or distributed system. You can't start distributed system without cluster operating system. That was the basic understanding. Yeah. Then databases and Hadoop. This is the just quick differences between RDBMS database and Hadoop. So it is it used to use SQL. It used Hive SQL. Hive came in picture later on. I will explain you why Hive came and what was where the Hadoop was failed, then a Hive came and then saved somehow. That also failed later on, and then PySpark came. And then it is having its own SQL scripting language. This introduced the Pig scripting language, then programming language interface, and both having the programming language interfaces. Yeah, programming language means I told na, right, it is having JDBC ODBC connection. By that you can give the strength of program like loop and functions also, or class also, to the data. And here also there is a programming structure approaches by Java. It can be do by Java on Hadoop. Then in this lecture, what we are going to now, we are going to see, this is chapter 2, 813. Okay, what is the Hadoop and how it work? Where did it come from? Challenges with Hadoop and entering in Apache Spark, and then data lake and house. Like currently everything is working on data lake and data lake house. Lake house is there. So Hadoop is a distributed data processing platform that offers the following core capabilities: Yarn, HDFC, and MapReduce. Yarn is the manager, cluster resource manager. HDFC is the distributed storage, and Map and Reduce is the operation or distributed computing operations. Functions running the programs. Okay, MapReduce running the programs. That much you can understand. What is the full form of yarn? Yet another resource manager. So that is the full form. That means Hadoop cluster operating system, popularly known as Hadoop cluster resource manager, and it is having three things: RM, NM, AM, resource manager, node manager, and application master. What is the meaning? Just you'll understand by this picture. Like this is your distributed system. So it will have a master slave approach. One processor or one machine server, one server or one processor, we can not processor, one machine we can say better. Okay, every machine have their own CPU, hard disk, RAM. Okay, so four, one, two, three, five machines, five their own server CPU. Okay, so this one is master, and remaining are slaves or worker nodes. One is master node, another are worker nodes. So master worker or master slave approach was there, and here there was a resource manager. Yarn runs as resource manager on master. Okay, so what was the Yarn manager? A resource manager, we can say, a program written for managing every node. That is the Yarn, and that the Yarn was installed or run on top of this one master node, which one node is declared as a master node on which the Yarn will run. Yarn means master node or resource manager node. Resource manager will run on that. Okay, then there is a node manager. Two things are there: resource manager and node manager. So resource manager program will run on the master node, that is only called the Yarn, and node manager will run here. Why there is different type of managers? Why? Can you think and tell? It's based on common sense also, actually. See, if we distribute the things on several different nodes, if you have suppose lots of books are there and you distribute it into a library rooms, 3-4 rooms of the library, okay, then you need a manager also to have a records what thing is on which room for access. Like if you need a physics book, so it is stored in room 1, room 2, or room 3, you should have prior information before storing, right? When you are storing or arranging your books in a library, so you will have room 1 dedicated for physics. Suppose I'm just giving analogy. Mathematical books is in room 2, science books are in room 3. So if you need physics book, you can know, you know that room 1 having physics book, and inside that also many shelves are there. So which particular section of physics book is on which shelf, that also further information you need. So you need all the metadata. Early days they maintain in a register in college, right? That this rack has this books, this rack 2 has this book, this room 1 has this type of books. All the information metadata they maintain, right? So and that metadata need to be managed by some manager. If you need anything, you need to go to manager, ask where is what. So it will have some management thing. So this is resource manager and node manager. Every particular have node manager that will have labeled data and all. What data is coming here, that information, and what data is going from here, that information. So resource manager, node manager. Then application master, which used to run entire application. Like this is application master, which is going to run one application at a time. This is another application master, like that. We are not going more complex detail, just understanding basic Yarn and basic this HDFS and map and reduce. That much will be enough. So Yarn means you can understand this much. Manager. Yarn is a manager, resource manager, and node manager. Resource manager run on master and node manager on workers. Now, Hadoop distributed file system. So managers are there in Yarn level. Now there is a metadata information I told, right? So those information are kept like a register we used to keep in library, that is kept using Hadoop. So Hadoop having the metadata, it is a distributed storage on Hadoop cluster, has two main component, name node and data node. So Data node is on data, name node is on master. And it will store, primary purpose of HDFS is to store or save the file on Hadoop cluster. Hadoop cluster means if you receive the data file here on master, it will divide it into the workers. So it need to store it into the workers or clusters. One is storing, writing. Another is whenever is query will be fired by the user, like select star or anything want to read. So reading, writing, reading. Two things are there, which was the primary purpose of HDFC. So whenever the writing command or file copy command was fired, then the HDFC will divide it into the chunks, and after dividing, write those parts on data nodes. So suppose those six parts was there, so two at a time to three. On three nodes, each part is called the file blocks. Each file will have a typical 128 MB size. So one file block can be written in here. So if there are some different partition methodologies there, according to that will be distributed on different nodes. So suppose this is one example that that six parts are divided two each in a round robin fashion, you can say. That is some terms I'm using. Just there are different partitioning methods. If you are not aware, you can search that and understand what are the different partitioning methodology. That is very important in every programming language. Okay, so this different partition, or otherwise I will take some lecture later on what is different partitioning methodology, indexing and partitioning. So like this. So in the Hadoop, the one block size was typically 120 MB confirmed like that. So it will name node facilitate the process and keep the track on file metadata, right? So this will distribute, name node will distribute and keep on data node, but it will track the metadata as well. Metadata means file name, directory location, like here this data node will have some directory uh, like we have in Windows C drive. In Linux, root is there, right? Like that. So like root folder, it will have data node will have the directory structure. So on which location, which part is, so the information about the data partition is stored in name node. Information means file 1 has, suppose file 1 is the name, file1.txt of 128 MB size. So that is stored on this location. So it will have an entire full-fledged path, /host /this /that /file1.txt. This is the files path. So this will have all controlling information, metadata information of file name, direct main file name, also main file name, main file size, main file location, and the file blocks. These blocks are stored here. So block ID, block name, block location, that is the data nodes data nodes information controlling the data node, right? That is happening on this name master node. So in name node it is storing, and that Yarn resource manager will use it and do the processing, manage. How Yarn will manage? Yarn can manage by the help of HDFC only. So they all three layers are working in together. Okay, working together. So Hadoop is basic combination of three layers, and they are working together. HDFC is storing the data, keeping track of everything. Like if you have a big library, so first of all you will store the data there, the books there, and then you will have a track. You will maintain a register. Okay, you will have a track. Room 1 having physics, room 2 having this, that. So all is stored in this name node. Then if anything is needed, you will go to some clerk or some person, manager person. You will ask, I need a physics book. So he will issue you physics book. He will check the register name node, and it will go to that room, will fetch it and will give you. Means he will not, he will tell to clerk and that will give you. So that management work, like seeing this, using this HDFC metadata, name node metadata, and processing work, using and processing, it is done by manager Yarn. and storing and retrieving work, storing and distributing, maintaining the where it has distributed, and collecting back, that is done by HDFC. Now collecting back operation. Write operation we have seen, read operation. If customer is fired the query, select star from particular table, diamond table, okay, with some condition or without condition. So how it will retrieve the data? So first of all, everything will go to master first. Any query, any thing will go to master only. So master will send the query. Read operation will call to the name node or master, and name node will call to data nodes, and all files which is stored on data nodes will be collected back. How it will collect back? By the information it has, the data block information, data block ID, location, all things are there. From that information, metadata information, it will call back by read API and assemble the file by metadata provided by name node and give it to user. So this is what is the yarn in HDFC. And now the MapReduce framework, that was very important at that time, and currently PySpark has overruled this. MapReduce is no more, but we need to understand what was the framework and what issue came actually. So programming model and framework model, two models was there in MapReduce. This is the third layer and last layer of Hadoop. Right, for understanding it was a functions, nothing but a programs. Okay, so two things was there, programming model and programming framework. So model is technically solve the problem, and framework will use the model and reduce it. Reducing framework and map model, two things. Right. So this suppose we can understand this with one problem statement. Suppose you have a 20 terabyte, a huge file of 20 terabyte, and you need to count the number of lines. On Unix we can write wc-l, right, command, and can count the total number of lines. Yeah, but 20 terabyte file it is. So if it is stored on a single server, it will take 4 to 5 minutes. If you do that, wc-l is what actually it is doing this kind of thing only. It is the entire files. Python, if you know, you can understand this code very easily. So this is one pseudo code. Either you do by Java or Python or any language, or in Unix also in backend going on. So what will happen? You will have a fhd.getLine, like total number of line will be here. Or we do Python. I will show you the file operations. In that also we will do this kind of coding little bit. So this total number of lines, and one line at a time it will pick, and will counter will increase with 1 2 3 4 like that. So how many lines are there, it will point to one by one all lines, and counter will go on increasing till the end of the line, and it will return that count value, print that count value, return that. If it is function, it will return that, like that. That is the basic approach, right? Easy to counting the number of records in a file. It's an easy approach, but here what is the issue? It will take 4 to 5 hours actually for processing this much 20 terabyte file on a single machine, if it is on single machine in RDBMS kind of thing. So now what about the Hadoop? So solution is that like this. Hadoop can have a in Hadoop you can have a 1 2 3 5 into 4 20 plus 1 21 nodes. In that, one is the master nodes and remaining 20 are worker nodes, and each worker node or each node is having 4 hard disk, 2 terabyte each. So total one node having 8 terabyte capacity, hard disk capacity, and 4 dual core, that means 8 CPU, and 4 16 GB RAM, 64 GB RAM. So this is the capacity of 8 TB, 8 CPU, 64 RAM capacity of one node. So entire unit will have how much capacity? You can multiply by 20. 20 worker node, that means multiply by 20. 160, entire system will can store 160 terabyte of data. It can have 8 into 20, 160 CPU, and 64 into 20, 12 12800, right? Or 12800. That much RAM for processing. That much GB RAM for processing. Okay. So that is the entire capability or strength of the entire system in a distributed manner. Now, what will happen? It can store 20 terabyte file. Yes, it can store even 8 into 20. That means 160 terabyte it can store. So 20, what it will do? It will divide it into chunks. And suppose it is stored on 1, 2, 3, 4, 5, 6, 20 minus 6, 14, 14 systems, 14 nodes, worker nodes. So what resource manager will do? It will divide the data onto the working nodes, 14 working nodes, and name node will store their metadata information, which file going to which location, right? The first name node will have all the metadata of big 20 terabyte file. What is the name, size, location, and then it will have information of each and every data node, that what is going where, so that it can collect back later on, right? So now what will happen? Instead of file, it will work on the file. So here in the previous code, we have seen that it was working on entire file. That's why it was taking time. Now, in our case, in Hadoop, it will not work on entire file. It will work on file. Yeah, hello everyone. Am I audible? Hello.
Yes, you are audible now.
Okay. Happened. Screen is visible, guys. Hello everyone, screen is visible?
Yes, screen is visible.
Yeah, okay. I have joined mobile data, that's why it might be a little issue. Right, so in map and reduce, we were seeing that. So what happened in map and reduce, like first of all, it will do this file block on one block, it will do counting. Right? And then after running the map function, you will have the count of or lines, count of lines on every node. This map function will open each and every file block chunk and then count the line. So we will have on one node, what is the will have add on another node on another, like at the end of execution of map function, it will have count of each block on every node. Then all the 14 on that side will be working parallel and count parallel and uh, RM like not so reduce function. Reduce function will connect counter and then it will write it into the list format. Okay, all nodes, data nodes will return count like oh, it count 50, it is 100, it is 1000, it is 1000. We all will in a list format, list of numbers, list of counters like this from all the 14 nodes. That function will loop through and count the final list count. Each count and list count, total count equal to that will reduce with the sum of count. Instead of counting in single file, it has divided the functions also into two. One is counting on every block and the other one combining. So dividing the data, working parallelly on every node, and then combining the counter or the result back and combine that and then returning the result. It is the basic process of map and reduce. Hello.
Yeah.
Yeah, actually, this today some electricity work is going on, I think. So we will conclude here for today's session. Okay.
Sure. Yeah.
This Google Colab and Databricks, regarding this, you can search in Google Colab, and just do a login by your email ID. And Databricks also, I will share the link if you don't know, login.databricks.com. So just make your account. By it will ask from sign in by Google. So by your Gmail, you can make your own account on Databricks as well as on Google Colab. Okay.
Yeah. Okay.
Right. So
Databricks,
we
it
will
is
conclude
30
for
days
today.
validity, right? Only 30.
Databricks, I don't think 30 days. It is available for how many days? Earlier it was 30. Recheck one. First, we will learn Google basics.
Okay, fine. We'll check. I'll check and out.
Generally, Snowflake Cloud has 30-day validity, but Databricks is also 30-day validity, or need to recheck. But first, at least do on Google Colab. Tomorrow we will start the Python, and before that, I will just give you a quick understanding on after Hadoop that how the Spark started and what we do on PySpark, basic understanding. That will be there tomorrow, and then we will start Python.
Yeah, sure. Okay.
So on today's session, I will write some assignment questions and will send the group. So you can prepare some notes on that for yourself and understanding. Yeah. Uh, so based on the interview, the assignment and notes, the questions will be based on interview questions. So that's why if you maintain your own notes on those assignments, it will be helpful for revision at any time. Right. So okay. Bye everyone. Conclude.
Yeah.